Good day, everyone. The topic that we will be discussing today is about the derivatives of inverse trigonometric functions. Before we are going to start or to have some kind of examples, we must first identify all the formulas that could be used in order to solve this kind of equations. So the first formula that we will be using with regards to the inverse trigonometric functions is the derivative of arcsine u with respect to x. This is equals to du dx, the derivative of u with respect to x, over the square root of 1 minus u squared. Next one, the derivative of cosine raised to negative 1 with respect to u, or r cosine with respect to x. This is equals to the derivative of u with respect to dx, negative d with respect to x over the square root of 1 minus u squared. Also, the derivative of arctangent u with respect to x. This equals to du dx over the square 1 plus u squared. Next is, let's try the arc cosecant. The derivative of arc cosecant u dx with respect to x. This is equals to, this is equals to negative du dx over u times the square root of u squared minus 1. Next one is the derivative of arc secant with respect to x. This is equals to du dx over u times the square root of u squared minus 1. And the last one, the last formula that we will be using is the derivative of arc cotangent u with respect to x. This equals to the derivative of negative derivative of u with respect to x over the 1 plus u squared. So these are the formulas that we will be using as we are going to solve some kind of problems that are involving inverse trigonometric functions. Okay, now let's try some example. So our first example, our y is equals to the arctangent of 3x. So we are using these trigonometric functions later. Okay, so our first example is y is equals to tangent raised to negative 1, 3x. So we are going to find for the y prime or the dy dx. So first thing to do is we need to let u is equals to 3x, and then let's derive directly the derivative of u with respect to x. So this is equals to 3, and then if we're going to rewrite our equation, since we let u equals to 3x, we could say that our y, this is equals to the arctangent of u. Okay, And then we know that if you're going to derive this one with respect to x, we came up with our equation number 3. So in here, okay? So this is in here. So we could say that the derivative of y with respect to x, or the derivative of arctangent u, is equal to du over dx over 1 plus u. Now, since we already have our u and du dx, so we could be able to substitute them in the given in our formula. So therefore, our dy dx is equals to du dx is 3 over 1 plus u squared is, our u is 3x u squared. So overall, our dy dx, this is equals to 3 over 1 plus 9x squared. So this is our answer. Our example number 2, we have y is equals to r cosecant of the square root of x. Okay, so we can say that this equation is under the derivative of inverse trigonometric function because it has an r cosecant. And then first step is we need to use a letting. We let u is equals to the square root of x. So at this point we could be able to derive this one. Let's derive it directly. The derivative of u with respect to x, this is also equal to raised to 1/2, and then we need to bring down the exponent, which is 1/2 x raised to 1/2 minus 1, this is equals to negative 1/2, and then the derivative of x with respect to x. Okay, so we can be able to stop here because this is already at dx over dx, which is equal to 1. So we must stop here. So we can say that our du dx is equals to 1/2 x raised to negative 1/2. Next is, if we are going to rewrite this one in this equation, we could say that this is equal to y is equals to the r cosecant of u. So therefore, if we are going to check based on the derivatives of, or I mean the formulas of the derivatives of inverse trigonometric functions, this we could say that we could be able to use this equation. Okay, and then based on that equation, the derivative of cosecant r cosecant u, or cosecant raised to negative 1 of u respect to x, this is equals to negative du dx over u times the square root of u squared minus 1. And since our problem, we already have our u and we already have our du dx, which is equal to 1/2 x raised to negative 1/2, therefore we could say that next step is a direct substitution. So dy dx is equals to negative 1/2. Substitute du dx is negative 1/2, since we have a negative here, so negative 1/2 x raised to negative 1/2 over the square root, no, u is square root of x, yes, square root of x times the square root of u squared, square root of x squared minus 1. Okay, next step is, let's try to simplify the numerator. So we could be able to write this one as 1 over 2 square root of x divided by, so if we put the x, or x raised to 1/2, this will become in a 1 over 2, or if we're going to put the x raised to negative 1/2 to in the denominator, we can be able to reverse or invert the sign, which will become x raised to 1/2. And then also this the square of x, the square sign will be cancelled, and also the square, so the remained uh the x will remain. So we have here square root of x times the square root of x minus 1. So next step is, so we try to simplify this one. So if we have, so negative 1 over 2 times the square root of x. So since here we have also a divisor of 1 here, and then if we're going to invert the division from multiplication, we need to multiply it by its reciprocal, by the reciprocal of the denominator. So instead of square root of x times square root of x minus 1 over 1, we will invert this one into 1 over the square root of x times the square root of x minus 1. So again, we know that the square root of x times the square root of x, this is automatic equal to x. Okay, so the square root of x times the square root of x, we know that this is equals to x raised to 1 half times x raised to 1 half, and we know that 1 half plus 1 half is 1, so therefore we can say that is equals to x raised to 1, or x. So our answer would be 1 over 2 x, the square root of x minus 1. So this is our answer. Our example number 3, we have y is equals to the arc sine of 4x raised to 2. So based on by inspection, we could say that we could be able to apply the power rule because we are involving a power here which is equals to 2. So we can say that, let's try to use a substitution method. Let v is equals to sine raised to negative 1 of 4x, and then our n is equal to 2. So therefore we could be able to rewrite our equation in here. We can say that our y is equals to v raised to n. Okay, and if we're going to derive the y with respect to x, we can say that this is equals to n v raised to n minus 1, the derivative of v with respect to x. So at this point, what we need now is just the derivative of v with respect to x, so based in here. So at this point, if we derive dv with respect to x, we know that this is equals to sine raised to negative 1, or arc sine of 4x. So we let again u, let's use u is equals to 4x. So to find so in order for us to solve for dv dx, we need to let again u with u equals to u equals to 4x. So our du dx, this is equals to 4, and then if we are going to rewrite our equation, v is equal to sine raised to negative 1 v 4x, this is equal to v is equals to sine raised to negative 1 of u. Okay, so to solve for dv dx, we are now involving the inverse trigonometric function, and we could be able to use again the first equation here. The arc sine u is equals to du dx over the square root of 1 minus u squared. So therefore, our du dx is 4 over the square root of 1 minus u squared. 1 minus u squared is 4x. 4x squared. 4x squared, or this is equals to 4 over the square root of 1 plus, minus 16. This is 16x squared. So therefore, at this point, we could be able to use or no, we could try to simplify this one. So after that, so let's check in our general formula, dy dx is equals to nv. So our formula in here, so we know that dy dx is equals to n v times raised to n minus 1 dv dx. So after since our n is already here equals to 2, v is equal to sine raised to negative 1 of 4x, or arc sine of 4x, then our dv dx is already derived, which is equals to 4 over the square root of 1 minus 16x squared. So at this point we could be able to the next step is the direct substitution. So dy dx is equals to n is 2, v is arc sine of 4x, and then n minus 1, 2 minus 1 is already 1, and then our dv dx is equals to 4 over 1 minus 6, the square root of 16x squared. So this is our answer. Or if you're going to simplify, dy dx is equals to 8 arc sine of 4x over the square root of 1 minus 16x squared. So this is our answer now.